get on to Johnathan. Johnathan Rush is with the CyberGIS Center for Advanced Digital and Spatial Studies, a new center at the University of Illinois, and he's the Director of Outreach and Education for the CyberGIS, for the center, actually, and works with CyberGIS projects.
He's also a power user of Rishi's software. I was really impressed with Jonathan's quick adoption.
The thing I didn't know about Johnathan until the day before yesterday is he had a year's worth of professional expertise with the Franklin County?
Champaign County, Illinois.
Yeah.
For transportation?
Mm-hmm.
Oh, okay. Well, a year in transportation planning.
Well, it's a testament to Rishi software and the quality of the data and the people I work with that I was able to catch up very quickly. I came in halfway through the day on Wednesday, and I was really worried about being able to catch up, and I felt like it was pretty, I don't know, it was set up really well. So it was a great experience working with everybody. Tim mentioned earlier that I am also at Ohio State, where I am working on the never-ending PhD project. But that's a little bit related to some of the interests here. I'm working on a web GIS for oral history, so it's a qualitative GIS sort of thing. So I'm very interested in how we can get CyberGIS to interface more with humanities GIS and humanistic exploration. I don't have the answers, but I'm very interested in exploring those over time with everybody. Today, though, I'm wearing my Illinois hat, and I'm going to talk about a couple of resources that we're helping coordinate through the University of Illinois. And the first one I'll talk about is our new CyberGIS supercomputer, and then also the CyberGIS Fellows project, which is one of our educational projects. So we have a brand new CyberGIS supercomputer. It's the first dedicated supercomputer for CyberGIS exploration. We're calling it Roger. We had a naming competition, and the name that we chose was Roger after Roger Tomlinson, and it's an acronym or backronym, considering whichever we consider to be more important. Resourcing Open Geospatial Education and Research. The performance estimate down there is around 60 teraflops. It's completely hypothetical. We haven't benchmarked it, but that gives you a ballpark compared to some other systems. But why did we want a new CyberGIS supercomputer? At the CyberGIS Center at Illinois, we have long used supercomputing resources located around the country. You may have heard of a network called Exceed. Exceed is a very really cool program where not every campus has a lot of supercomputing resources, but you can apply to use the supercomputing resources at other campuses networked throughout the country if you have a good project. So it doesn't matter if you're at a community college or if you're at a Big Ten university. If you have a good project, you can get an allocation, which is great. It's a wonderful resource, but it is really, for the most part, traditional HPC batch job sort of thing. So you write a script that defines the operations you want to run, and you put it in line. And you don't get a whole lot of feedback on when your job's actually going to run. So in the sort of scenarios we were talking about over the last couple of days in a planning context, you wouldn't be able to get live feedback over the course of sitting in this room. You were often lucky to get your job to run in the next hour or two, and you just don't know. You'll know when it starts and you'll know when it's done. So our project for Roger does support the traditional batch HPC mode. We do have a number of research projects that it doesn't matter when exactly they run, only that they run and they run quickly. But we also have a couple of other modes. There's the Hadoop framework, the distributed database with the MapReduce operations. There are some operations that map very well to that paradigm, so we're supporting that, as well as this cloud environment. Cloud is much more set up for an on-demand processing. It's also some place that we could run long-living web services and products that have to exist over the longer term that aren't just running a model and getting the results once. One of the reasons for this, besides the fit to each individual paradigm, is we have a lot of collaborations. A lot of people will approach the group, and we don't want to say we'd love to work with you. However, you need to refactor everything you've done into the paradigm we support. So the other reason for this is flexibility. A smaller concern I recently learned about is university purchasing challenges. Now, this will vary based on where you are. University of Illinois has perhaps some of the strangest rules because Illinois' unique politics and history. You might know something about some of our governors who may or may not be in prison right now. That has led to a lot of restrictions in university spending, which I know every university has to deal with in one way or another, and it basically results where it is impossible for us to buy cloud resources from Microsoft, Amazon, Google, anybody, not unless you want to pay for them out of pocket and never get reimbursed. So this does not solve that problem for the university. It doesn't solve the problem for the College of Engineering that wants to have cloud resources for all of their students, but it solves it for our research domain in that we now can have our own cloud resources because we're running on our box. So small pro for that, we're talking about solving a couple practical concerns for actually doing this kind of research. It is both something that we research how to do CyberGIS better, but it's also a resource for us to do actual getting work done and research completed. A quick brief on what's actually in the box. To some of you this will be Greek, but to computer geeks like myself, it's kind of nice to see what's actually running on it. That's how we've split up the 3 paradigms for now. We have 52 computing nodes, some of which we have dedicated to the traditional HPC. Many of those also have GPU nodes for jobs that benefit from that. We have the high memory nodes, which have double the RAM, and instead of a local hard drive, a local SSD, which is a bit larger and much faster. That's dedicated to Hadoop. And then we have servers that are set up for our file system, and I believe for the cloud, we're actually using some of the high memory nodes as well. We have some future work to do in making this split a bit more dynamic. Right now, each one of those has a sort of set install. Conceptually, it's not very difficult to move one from one membership in one group to the other, but as a practical matter, doing it on the fly is a bit difficult. We're hoping to smooth that out so we can adapt the resources more quickly. We designed this to the extent that we know now for what a supercomputer for GIS would look like. So memory was important, and disk storage that is fast and accessible across all the different kinds of resources was also important. So the disks are set up a bit differently than what you have in a traditional Hadoop cluster or even in your regular desktop. We have NetApp servers that put all your disks in trays, and it has their own version of RAID for accessing storage distributed across many different nodes, so it's very fast and accessible no matter whether you're in the cloud portion or the traditional HPC or Hadoop or whatever. So your regular disk access across all the nodes is supposed to be very quick. We have about half a petabyte, 500 terabytes installed right now, hopefully up to about 4 terabytes. I'm not sure if that's pre or post formatting after we get the rest of our disks in. The rest of the hardware that was installed. You can see this info and a bit more if you check out this link. What we're doing all this for, and some things we're excited about in the future, is we can have all of our data analytics and visualization co-located on the same system. Now, of course, one of the reasons we do CyberGIS is that we have web services that can link a lot of things together. Of course, we still want to do that, but of course, you get better performance if you can actually get all these things located in the same place when possible. We are doing some explorations, though, for whether or not this is necessary and in what cases it's necessary. So, for instance, on the southern part of campus at Illinois, we have the State Geological Survey, and they are the administrators of the LiDAR data sets for the state of Illinois. We have about 2/3 coverage for the state right now. Other states are complete. Neighboring Indiana has LiDAR coverage for the entire state. Around the country, this is progressing with the USGS 3DET program. It's quite a bit of data, and we could store it on Roger. We're exploring whether or not we have to. We should have somewhere between a 1 or 10 gigabits per second link to their server. We'd like to find out if that's enough, because it would be nice to store the data in one place for the sake of provenance, for the sake of communicating where the data is, and for not wasting everyone's storage and bandwidth and things like that. One of the advantages of the cloud, which we're getting through OpenStack, is that, for instance, you can generate a lot of data through the HPC or Hadoop portions, and then use the cloud to visualize it and make it available via web services. You can also use the cloud VMs, which you get a lot more flexibility on. We can give somebody access to a virtual machine where they can have root access, where they can't mess up as many things, right? In traditional HPC, each one of those mini computers that are all linked together is its own Linux machine. And you don't typically give people access to modify those because you'll break it for everybody else because they're shared resources. However, you can be much more flexible in a virtual machine, let somebody act as root, install anything they need to actually get work done, so you can support rapid prototyping that way. I mentioned the advantages of the shared file system. We're still working on a little bit of user account stuff, but eventually you can be members of a group and have all of your data access linked across whichever systems you're using. I mentioned the dynamic reallocation. Those of you who've heard of Globus, we can use the Globus endpoint on the system to move data very quickly between either your individual machine and the cluster, using theoretically as much bandwidth as possible from your machine there. I maxed out my gigabit connector on my laptop, so that's decent performance if you're on a nice local machine network. But of course, even faster if you're sending data from one campus to another via Internet 2 connections, or from an Exceed cluster to that, so we can move data around very quickly. My job at University of Illinois is the Education Outreach and Training Coordinator, so I'm particularly interested in how we can use this for EOT. And some examples of that is we could, for teaching purposes, when we're doing our training workshops, or when someone's leading a course, we could make cloud instances for everyone to use where they could learn whole stack WebGIS. And we're using WebGIS very heavily in CyberGIS paradigm. So if they want to learn the Esri stack from databases all the way to services or open source stacks, we'd be able to do that so they really understand the entire system. We've done a few workshops now where people have run a little bit of, say, HPC code and learned a little bit of how we've done CyberGIS at University of Illinois. But there's a lot of literacies that people have to learn in a hurry. Traditional GIS people don't know streaming data paradigms. They don't typically know the bash shell. All these things they have to learn kind of quickly. We can smooth some of this out and teach some of the concepts bit by bit if we do things like use a web notebook for doing computing. So we can run Python, IPython in a Jupyter notebook. We can run RStudio online and abstract out some of the issues we have with having people install software in their machines and making sure they're ready for the workshop, which is always a pain point whenever you do a workshop that has hands-on components. And finally, we can have allocations for students and trainees. The CyberGIS Fellows Project is an effort to get materials available for instructors to use to keep their students up to speed on the latest in CyberGIS technology. CyberGIS is so rapidly moving and evolving that it's not really appropriate at this juncture to have a textbook for CyberGIS to be rapidly outdated, nor is there much materials to really share anyway. So we have 17 fellows working together on 13 projects who each propose something in their interest area that they could research CyberGIS and produce materials that they would all share. So very soon we'll have deliverables from all these people that will be going on a website that will make that available. At the AAG conference just a couple weeks ago in Chicago, we held a workshop on 4 of these projects where very briefly, we only had 45 minutes for each one, we gave a hands-on component of something they had worked on. And we got some very valuable feedback from the participants on how that would work in their context, how they would teach it or learn from those materials. This is what we did at AAG just to give you kind of a sampling of the kind of things we're getting from the fellows so far. We had Google Earth Engine. Jim and Britta worked on social media in the classrooms, and that was an example of just teaching students how to use APIs. I mentioned that streaming data is something that traditional GIS operations don't take a lot of advantage of. They use the example of just the Instagram API. Very consumable, understandable example for undergraduates to get a handle on using Python, and you dump a whole lot of geolocated photos into a database, so it kind of smooths over that transition. Eric Shook has the parallel cartographic modeling language. And Ian Nina, this title doesn't tell you much other than it's HPC for Python geocomputation, but their project is actually about looking at the effects in the southern Mississippi Basin near the coast of Louisiana on sea level rise, subsidence, flooding, all the effects related to that. You can very much imagine that in a geodesign framework, and so they're taking advantage of CyberGIS for that. I mention this because not only have they been tasked with coming up with teaching material for CyberGIS and the problem-solving skills required for that, we're thinking about doing a second call. I believe it's in the budget. This hasn't been finally decided. But regardless, some of the future possibilities for this kind of project in the future are to take a look at what we have so far, and hopefully everything that we have so far will be made available on a website around the end of the summer. We're going to try to identify and address any gaps in the materials. We're going to try to improve the pedagogical techniques for CyberGIS education, but we're also looking towards some sort of sustainable repository sharing collaboration place for these kind of materials over the long term. And I say post-funding because the original CyberGIS software grant is wrapping up. So whether this means additional funding in the form of another grant that can support this kind of thing over the longer term, collaborating with some other existing framework for this kind of thing, perhaps Haystack, or some other place where materials can be grouped and shared, or whether it is entirely crowdsourced, non-funded website where these things can simply continue to be shared and contributed. There needs to be some sustainable framework for this in the future as CyberGIS becomes sort of mainstream GIS, and we have to get students, faculty, grad students all up to date on that. So yeah, that's all I have to share. Does anyone have any questions?
Who built Roger?
who built Roger.
Yeah.
Um,
I
so-
imagine you guys all sitting around in pajamas all night.
That would have been fun, but I am now somewhat relieved that's not what happened. So I am kind of a long-time computer geek, and I thought this was the kind of thing that I could theoretically do. I was wrong. There is, yes, this is commodity hardware. It's 52 plus once the support nodes are involved. It's just Dell 2U racks. But there is a lot of expertise at NCSA in running these things. It sits right next to Blue Waters, which
Yeah.
is 4th, 5th, 6th, somewhere around there, fastest supercomputer in the world. And their expertise was absolutely invaluable. And the devil is in the details, and there are so many details and devils to be worked out. It took we started getting the parts in late fall, and it really, the switch wasn't flipped on until a couple months ago, and we're still working out little details. But that's the difference in having a really stable, reliable resource over the course of a few years until it gets outdated. And so it really couldn't have been done without a supercomputer center's help.
Yeah.
I'm glad that they're managing those bits.
Thanks, Jonathan.